So hello my friends, welcome back to the lab, and today in the lab I have a lesson that I want us to talk about. Well, and the thing I want us to talk about today is these little components here. This component is what is known as a transistor. Now transistors are semiconductor devices that are used to switch signals or to amplify signals. And transistors, they are the basic building blocks for the modern electronics. And in order for us to do that, to understand well how these components works, we need to do some experiments, and we look at how you can apply one of these. And one way of doing that is taking a pen and a paper and having some demonstrations. So we are going to build some real life circuits on how you can do this. I mean on how you can use one of these components, and what better way of doing that other than just getting right into it. Well, let's just do that. So we are at the bench, and today we are going to be doing an introduction to the device that is known as the transistor. So by definition, a transistor is an electronic component or a device that is used to switch or amplify an electric signal. So those are the two main uses of any transistor. So you can either use it as a switch, or you can use it to amplify an electric signal. Now, when it comes to modern electronics, transistors are the basic building blocks for the modern electronics. And with that being said, that means that this device here is one of the most, arguably if not the most, one of the most important electronic device out there. If you take something like your mobile phone, this is a motherboard from a smartphone, you can argue that the most important, or rather the biggest component in this something like a computer or a mobile phone, will be your processor. But then this processor is just transistors, millions of tiny transistors that are packaged together to form these processors. So there are millions of tiny transistors connected and configured in a circuit so that they can deliver the desired functions. So transistors are one of the most important devices when it comes to modern electronics. Now let's dive right into it and learn more about these tiny devices. So a transistor is made out of a material that is known as a semiconductor material. And when it comes to transistors, we have two materials that we consider, and that is silicon and germanium. Now this material is known as a semiconductor simply because its electrical conductivity lies between that of a good conductor and that of an insulator. It's because of that characteristic that you can actually alter how this material behaves when it comes to electrical conductivity. So the other thing about a transistor is that a transistor will have 3 pins. So these pins, or you can call them leads, and sometimes in layman's language people do call these legs. So these are the legs of your transistor. So each of these pins, it has a name, and in any circuit there is a way you are supposed to connect these pins. Now when it comes to transistors, we have two types of transistors that we need to look at. So the first type of a transistor is what are known as the BJTs. So BJTs stand for Bipolar Junction transistors. Just from the name bipolar means that we have two polarities and two junctions in these transistors. The other group or the other category is what are known the FETs or FETs. So FETs stand for field effect transistors. So in our today's video, we are going to be dwelling on this. So we are going to be talking about BJTs. So the main difference between these two is that BJTs are current controlled devices and FETs are voltage controlled devices. That means that in order to control our BJTs, we need to take care of current that is on one of the 3 pins. And FETs, we need to take care of the voltage on one of the 3 pins. Transistors come in different physical forms, and these forms, I mean in terms of shapes and sizes, and these forms are what are known as the transistor packages. So you can tell the difference between these two transistors. If we bring another one, you can see they still have 3 pins, but they look they are not the same in terms of physical appearance. So each of this package, or rather each of this shape and size, has a code, and I'll put the chart here for the code names for each of these packages, so you can refer to that. When it comes to BJTs, the 3 pins will be named as follows. So this is how the transistor will look like, and you will have your pins numbered 1, 2, and 3. Now when it comes to BJTs, these pins have a name. Pin number 1 is what is known as the base of the transistor. Pin number 2 is the collector of this transistor. Pin number 3 is your emitter, the emitter of the transistor. Another thing, when it comes to transistors, each transistor has a unique identifying number, and that number will be written on the face of the transistor. In my case, I have this this is a 2SA1943, so that number will be written somewhere there, not unless it's a proprietary device where the manufacturer decided not to put the name there, but most of these transistors will have a name, or rather will have a code that you can use to identify that transistor. Another thing, there is a naming scheme that is used for some transistors, and that will assist you in identifying that particular transistor. Now a transistor, or each of these transistors, have a datasheet. A datasheet is just a document that you can use to look up for the characteristics of each of these components. For example, there is a datasheet for my transistor here, and this datasheet will give all the characteristics that I need to know in order for me to use this transistor well. To where you can get the datasheet, again, not unless it's a proprietary thing, they are available on the internet. You can just go Google the part number. So this is the part number, and you will be able to download the datasheet. So make sure before you use a transistor, look up for the characteristics from its datasheet. Now another thing, depending on the package you have of the transistors, these pins might be interchanged depending on the package you have. So before you go ahead and connect a transistor, make sure you consult the pinout or the internet. You can also get the pinout from the datasheet. Now the pinout is just the physical layout of the pins with respect to how this device is oriented. If I orient this transistor like this will be my pin 1, pin 2, pin 3. Now a pinout will just tell you which pin is which. Okay, so before you use one of these devices, make sure you consult the datasheet and look up for the pinout. So now when it comes to BJTs, we have two types depending on the polarity. Now the first type of BJTs is PNP. The second type NPN. P stands for positive, N stands for negative, hence the name bipolar. And the middle letter here will always refer to the base of the transistor. If this is a PNP transistor, then the base will be negative while the other pins will be positive. In the case of a NPN, then the base will be positive and the other pins will be negatives. In knowing which transistor is a PNP or a NPN, this is where the naming scheme comes in. Now in this naming scheme where we have 2S, A, 2S, the first letter in the alphabet, A and B, stand for PNP. Okay, so if you have a transistor labeled 2SA or 2SB, that one is a PNP transistor. If you have a 2SC or a 2SD, that one is a NPN transistor, right? So this is where you have to check out for the naming scheme. Or the easiest thing, you just Google the part number and you are going to know whether your transistor is a PNP or a NPN. Now how do we draw a bipolar junction transistor? Now this is how we draw the transistors. Now this is the sign for a transistor, and sometimes the circle might not be there, so you might have these arrows without the circle. Still, that one denotes a transistor. Now how do we tell which side is your collector, your emitter, or your base? Now you see the arrow. Whenever you see this arrowhead, that side will be your emitter, even if this arrow is pointing towards the other side. Now the side where you have this, where these two lines meet, this denotes your base, and of course the other one will be your collector. The same case with this, where the arrow points towards the base, still this is a. Now when you see the arrow is pointing away from the base, that means your base is a positive, and hence this one is a NPN. In the case where the arrow is pointing towards the base, you have your PNP. Now remember, we say that these transistors, or rather the BJTs, we have two junctions. The first junction will be your base collector junction, this one, BC junction. The other junction will be your base emitter junction, your BE junction, hence the name bipolar junction. Just from the name, you have two junctions, BE and BC, base emitter, base collector. Now the next bit, we need to know how a transistor works, okay? And in order for us to do that, I need you to refer these three pins in layman's language, or rather in layman's terms. I want you to refer these pins as follows. Now the pin that is just from the name, collector, okay, understand this as a pin that collects, okay, it collects something. The emitter, it will emit, or rather it will give out. The base is your control, right? So in simpler terms, the collector, you connect it to the source, the emitter, you connect it to the output, and the base, you connect it to the control signal. Now there is an analogy that is used to teach how a transistor works, and that analogy is the water tap analogy. Now let's take a look at that analogy and see how a transistor works. When it comes to the water tap analogy, so you have a tap like this, and on the other end of the tap is connected to the pipe, where the pipe goes to the source of the water. The other side of the tap, and you have the other side is where the water will be coming out from the tap, and then you have your bucket there. So at the top is where you have the knob where you control the rate at which the water is coming out of the tap, and this is synonymous with the transistor. Now this side where the tap is connected to the pipe is where you will have your collector, collecting the water from the pipe. The other side where you get the water out of the tap will be your emitter, right? So this is your emitter, and at the top knob where you control the rate at which the water is coming out of the tap is the base. This is how a transistor works. If you fully open the tap, then a lot of water is going to come out. If you close the tap at the top, the water will stop coming out. Now if you drive, now by driving I mean, since this is a current control device, by applying a current at the base, that is driving the transistor. Now if you drive the transistor too hard, you are going to be increasing the amount of current that is flowing through the transistor. If you lower the current at the base, hence you are not driving the transistor as hard, then you are going to reduce the amount of current that is flowing through the transistor. That is the easiest way you can do in order to understand how this device works. Now there is a lot to learn when it comes to transistors, and also there are some calculations that you need to do when it comes to operating one of these devices, and this is just a basic introduction, and in the next video we are going to look at some of these applications. So we say that a transistor is used as a switch or an amplifier. So in the next video we are going to see how you do that, and hopefully you are going to learn something. So with that being said, I need to stop this video at this point. so that you can watch the next part. So make sure you watch the next part in order for us to learn. Well, see you next time.